In this video, we're going to look at the end behavior of a polynomial. That is what happens when x gets really large and when x gets really negative, like negative 100, negative 1000. So in other words, that's what happens way over to the right of the graph and way over to the left of the graph. And the thing that's really important is this leading term here, the an x to the power of n, whatever that might be. The x to the power of n, the n part of it tells us if we're going to have something that kind of looks like this, something that looks like a quadratic. The an tells us if we're going to have something that's kind of looking upside down, perhaps. And we'll look at that in more detail, what kinds of graphs these have in the second slide. For the moment, what we're going to do is we're going to look at just a simple example of what I mean by the end behavior. So if I just move over to the right and zoom in a little bit, we've got a polynomial over here, which is x cubed plus x. If we take some really big value of x, I've taken x equals 100 here, but it could be 1,000 or 1,000,000. If we plug this number into the polynomial, we'll end up with quite a large number. In this example, it's a very large positive number. This 100 cubed gives us 1,000,000, and then plus 100 is over here. The plus 100 isn't really that important compared to the million. So this x part here isn't really important. It's the x cubed that's the important part. And that x cubed is the leading term. And when you look at a polynomial and you want to know about the end behavior, that leading term is the important part. That tells you what's going to happen when x is a really large number. When x is a large number here, we get a large positive number. When x is a really negative number, we end up with a really negative number. And then if we were going to graph that, what that looks like if we graph it is that we have to start off way down on the bottom left, because after all, a negative value of x gives a really negative value of y. So we would start off way down on the bottom left, but then a positive value of y like a positive value of x like 100 gives us a really large value of y, large positive value of y. So we might end up with a graph that looks something like this. Now, of course, there could be all kinds of other things that might happen in between. We could start over here, go up, and all kinds of other things might happen in the meantime. But if that leading term is x cubed, then we're going to start at the bottom left and we're going to end at the top right. And that's what I mean by end behavior. Now, if we just zoom out again and just have a look at the rest of this sheet, what we have in here is quite a lot of detail about whether to decide if something starts at the top left or the top right. It's quite difficult to interpret it from here, but if your n is even, then you're going to have something that's going to be either looking like this, kind of like a quadratic. It's going to look like that if the number before the x squared or the x power of 4 is a positive number. So if the number before is a positive number and it's an even thing, it's going to look like this. If the number before is a negative number, then what's going to happen is you're going to have something that's going to be upside down. It's going to be like that. And then if you've got an odd number for your power, for the power of x in the leading term, then you're going to have something that's going to be kind of like the shape of a x cubed. It's going to start at the bottom left, end at the top right, unless the number before it is a negative number, in which case it starts at the top left and ends at the bottom right. And later I'll show you the graphs that correspond to this. It might make more sense when you see the graphs. So if you wanted to know the end behavior of this polynomial here, you don't need to worry about any of this stuff at the end. You can forget about it. You can, in fact, you can put a line through everything from here onwards. So all that matters really is the 2x to the power of 5 term. And so we're really just graphing what 2x to the power of 5 would look like at the end. Okay, so you would start somewhere, if you're graphing x to the power of 5, or a positive number times x to the power of 5, you would start on the bottom left and you would end on the top right. And so this might be something that would work, this graph here. If you're going to write that down more technically, you would say that as x goes towards infinity, right, as x goes towards infinity here, the polynomial is going to go also towards infinity. And as x goes towards negative infinity, way down at the bottom left, the y, the polynomial, is going to go towards negative infinity. Now, why is this finding about what happens at negative infinity when x is to the left and x is over to the right important? Well, it lets us know where to start the graph. If we know to start down here and to end up over here, then that at least tells us something. Now, it may be that we have lots and lots of wiggles in between, but often we can figure out what happens with these wiggles by figuring out what the x-intercepts might be. So we have an example down here. This example is 2x cubed plus 6x squared minus 8x. We don't really care about this part here to start off with. We just look at the 2x cubed. So we know it's going to start somewhere on the bottom left and end somewhere in the top right. That's what this 2x cubed tells us, that we start bottom left, we end over here. We might as well just remind ourselves that we're going to start way down here and we're going to end up here. Now the other pieces of this we can try to fill in by factorizing. If we take this expression and factorize it, well, 2x is a factor of each of these, so it's 2x times x squared plus 3x minus 4. We can also factorize the x squared plus 3x minus 4 to get x minus 1, x plus 4. If we're interested in where it crosses the x-axis, this function, we put this whole thing here equal to 0. And if we do that, that factor x that we have here corresponds to a 0, a crossing of the x-axis at 0, x equals 0. The factor x minus 1, from this factor here, if you put that equal to 0, you'll get the value x equal to 1. And then the x plus 4, that factor here, will correspond to x equals minus 4. And that's why we've got 0, 1, and minus 4 on this graph as our x-intercepts. So imagine you're going to try and graph that. Well, you would start on the bottom left. You would have to go through the x-axis here, so that you go through at x equals negative 4. At some point you're going to reach the maximum. We don't know if it's at the top or if it's below that, but we'll deal with that later. We have to then again cross the x-axis at 0 and then again cross it at 1. And then we keep on going because we know we've got to end somewhere up here. So we've got something that looks pretty much like it should do, just from the information that we've got. Now for more details on we can look at that slide too. We can look at rather the page 235. At the top of page 235, it gives you details. You can see that this thing here looks a little bit like x cubed. It would be if you had if n were some kind of odd power like 3 or 5 or 7 or 9, and the an, the number before it, were a positive number. This would be the same thing, but this would be if the an were a negative number. You'd start up here and you'd end up down here. Now, if the n is an even number, so 2, 4, 6, or 8, so if we have x squared, x to the power of 4, we would have this kind of thing if an is a positive number. But if it's not a positive number and it's an even degree, if n's even, we have something that looks like this.